Hello. So today we're going to be talking about how to find an angle when you have like an algebraic relation about it. This kind of skill is really useful for more complicated geometry problems. You have a bunch of triangles and other shapes and lines, and you're trying to, you're given some angles and you're trying to figure out other things, maybe even like prove that some things are similar. So what we have here is we have an angle theta, and we know that its supplement is 36 degrees fewer than theta. So one thing we can say right away is that the angle must be obtuse, and that is because whenever we look at a pair consisting of an angle and its supplement, then one of two things is possible. Either they consist of an acute angle and an obtuse angle in either order, or they consist of two right angles, right? And I've drawn the cases here, right? Right angles are 90 plus 90 equals 180. But if it's not right angles, if you have something in the supplementary angle to that thing, and we're talking about angles between 0 and 180 here, which is, pretty much, those are the only angles where you're going to be talking about supplementary and complementary angles anyway. Yeah, so we have, we have this angle here, we know that its supplement is actually smaller. So it can't be a right angle because the supplement of a right angle is exactly the same size, and it can't be an acute angle because the supplement of an acute angle is an obtuse angle, which is bigger. So this angle must be an obtuse angle, the supplement of which is indeed smaller. So the picture looks something like this. We have theta, then we have, which is obtuse, and then tinier, theta minus 36, which is acute. Okay, so what is theta going to be so that that works out? Is there any theta that satisfies it? Well, this is a linear equation, actually, because what we know about the supplement of theta is that it's equal to 180 minus theta, right? That's the definition of a supplement. It makes a straight line, so it adds up to 180 degrees because that's the degree measure of a straight line. So what we have here is that for this particular angle theta that we want to find, Greeks would have said theta, but I'll say theta because that's more familiar. 180 minus theta, its supplement is actually equal to theta minus 36. Now, this is just a linear equation in theta. We can solve it the same way we solve all linear equations. What we've done is taken this problem, taken the information in the problem, and figured out how to reduce it to a linear equation, which is the key thing to do. Initially, it seems like just sort of a weird requirement, like when did we learn about, angles that have supplements that are 36 less than them? It seems sort of random, but if you write it out, it turns out to be equivalent to something we already know about, which is a major theme in math. That's how you can solve all sorts of problems. So we turn this into this linear equation in theta. Its supplement 180 minus theta is equal to theta minus 36. So how do we solve this? Well, we can start out by adding theta to both sides. You want to do that rather than subtracting theta from both sides to move the right to the left, because we want a positive number multiplying theta, a positive coefficient on theta. So if we do that, we get rid of the theta on the left side, then we have 2 theta rather than 1 theta. 1 plus 1 theta is what we have, and still minus 36 on the right side. And now we'll switch the two sides of the equation, because we can always do that, just so we have theta stuff on the left side. That would give us 2 theta minus 36 is 180, and then add 36 to both sides, giving us 216. 180 plus 36 is 216. Okay, and so that's just dealing with the constant term after we got the like theta terms together. That's always how we solve linear equations, right? The first step is we get all the x terms, in this case theta, but it doesn't matter what symbol we use. My math mentor used to use rabbits. That's acceptable as well, though maybe don't do that on your homework. We get 2 theta on one side then, and we put the constants terms together on the other side. Then we just have this factor multiplying theta 2. We've got to divide that out, right? Divide both sides by 2. 216 divided by 2 is 108. You can do that without, long division or calculating it by just noting that 2 divided by 2 is 1, 16 divided by 2 is 8, right? Okay, so we get theta equals 108. Now we should just check if that makes sense. First of all, we said that we wanted an obtuse angle. Is 108 obtuse? Yeah, sure. Is 108 minus 36? Well, that's 72. Is that acute? Sure. Okay, and is it true that 180 minus 108, that's 72, is equal to 108 minus 36? Yeah, that's also 72. Okay, so we found the solution to this. There's only one solution. That's how linear equations always work. So the key was remembering that supplementary means that they add up to that 180 minus theta is the supplementary angle. That's what supplementary means. And if we were told the measure of that angle in terms of theta, then we have something in terms of theta in two different ways. It's 180 minus theta because it's the supplement, but it's also theta minus 36 by stipulation. And this equality, we've expressed in the same thing in two different ways, gives us a relationship that allows us to find what theta is. That's the theme that comes up time and again in math. If you can express the same thing in multiple ways, then you can learn more about the things in terms of which you're expressing it. Okay, so that's how you can deal with algebra problems like this. If it were asking about supplementary angles, complementary angles, if there are more angles, it would just give you like more equations. It's slightly different equations, but the principle would be the same. Okay.